As you know, I proposed additional engagement just to see that you excel in the examination which you are to write tomorrow. To ace that examination, there are few who have responded, and a good chunk of people, or mostly of jokers, I would say, who have chosen not to respond. They have much to explain, their nonchalance, their idiosyncrasies. I need to know from them, and there will be no cliche. I'm not to accept any harangue. I'm not to accept any caveat from anyone. And not only is that I'm not to take anything into account, but I'll hold you to account. I'll hold you to account and will ask questions for this complacency. Why were you complacent? And what is the reason to get everything which I have stated in the class in my capacity to pull you, as if it is water off duck's back? I would also request the authority to devise a methodology so that these are not seen to be repeated in the class. We should be reformist, but at times we need to exhibit retribution as well. So I seek the indulgence of higher echelon to devise a methodology so as to arrest these which, if do find way in system, will rot it. To the ones who did respond, I found one question deemed fit to solve here in the class. Rest can be done with the others. The question which I have got, which I would say is a repetition of what we did in PU1, or what you would have done in PU1, where there is a particle which is lying on the circumference of the cycle, and you have to find what is distance covered by the particle in one complete rotation of the cycle. We get it as 8r. So it's a redo of that question. Given to us is a structure, a semicircular arc, where lambda is varying as lambda naught sine of the angle theta, the mod of it. We are supposed to find what will be field generated at the center. So what will be field generated at the center? We'll take a segment quickly. This is the segment that I am taking. This is theta. This will be d theta to s. And the charge over here, dq, will be equal to lambda r d theta, which is from this equation lambda naught sine of the angle theta, the mod of it, into r d theta. Right? Visible? Field generated at this point will be in this direction. If we place positive charge everywhere, owing to lambda being positive, we place positive charge, field generated will be this way. This angle is theta. I think they have taken this angle as theta, so let me change it slightly. This angle is theta. Nothing changes over here. Just a moment. Nothing changes over here. The angle will be theta as shown. Okay. And accordingly we'll write d value, that is theta. This will come out to be theta to s. This will come out to be theta to s. So d is what to us? D will be 1 by 4 pi epsilon naught into dq. dq is lambda naught mod of sine theta into r d theta. This is dq for us, right? And what else we have over here? 1 by 4 pi epsilon naught divided by r square. As you know, this angle theta, this will also be theta, so we write cos of the angle theta here. And if it's dy, y taken upward, there will be a negative preface, a pretext negative to it, so this is a precursor. What next we have to do is lambda naught I'll keep as it is, 4 pi epsilon naught I'll keep as it is, negative common, and sine theta d theta here. So sine theta d theta will get me first an r in the denominator. Sine theta d theta. Now this is somewhere we need to be exercising caution. What will be sine theta d theta? When we take one segment, we are going clockwise, and the angle measurement will be negative, as you know, and anti-clockwise will be positive. So let us go first clockwise and then write sine as negative of sine theta for that segment. I'm going clockwise, negative sine theta d theta integration. Also we have cos theta. Let me introduce it. Let me just oppose it over here. Or introduce, just oppose. So what do we get from here? Negative negative, so negative negative will be a positive divided by 4 pi epsilon naught r, and sine theta d theta will get me cos 2 theta, right? Cos 2 theta by 2, isn't it? And as it is sine 2 theta, so there will be a negative sign here, right? This is what we'll be getting. We have just marked it as sine 2 theta and accordingly integrated, nothing much over here. Where to where we have to move 0 to minus of pi by 2. So this is the first part of it. Second part of it I can introduce over here itself. Let me make some space here per se. What I'll do is, the second part is what to us? Second part is, as you can see from here, minus minus I took, so it was a plus out. It was negative. Okay, let us do it separately, otherwise we'll get jumbled up here. No issues. So this is the first case. Second case will be negative of 4 pi epsilon r in the denominator, and then this factor will be cos theta, the other one will be sine theta. So cos theta, let me write that for you so that you get a clear picture. No shred of doubt, no sliver of doubt. This is d theta, and then integrated. So this will get me negative of 4 pi epsilon naught r. Visible? Yeah. And sine 2 theta, again sine 2 theta, so minus of cos 2 theta by 2. Limits from where to where? This side will be from 0 to pi by 2. 0 to pi by 2, that will be the limit for this segment. Okay, and what we have to do next is we have to just place the limit. So place the limits. I make space over here. It's lagging, so I'll stop over here and we'll come back in the next.